This video is sponsored by War Thunder. War Thunder is a realistic, free-to-play military vehicle combat game. It's available on PC, PS5, Xbox Series X, and previous generations as well. No need to purchase anything, just download and play. In this game, there are more than 2,000 historically accurate tanks, helicopters, ships, and other vehicles spanning the entire 20th century. They're all carefully built and incredibly detailed, operating in a realistic physics engine. It's an immersive gaming experience with real historical campaigns. Even the sound is awesome. And look, you can just jump in for a quick arcade game, which is great if you're pressed for time, just looking for something casual. I love that quick, easy, casual option. That's me, I'm a busy dude, but I like to relax, play a little games every now and again. Or you can go for realistic and, well, it's a bit more challenging, and by a bit, I mean a lot. And then the simulator, which is a lot more challenging. Right now, you guys can join 50 million worldwide players on the battlefield for free using the link below. And for those of you who do jump into the game using that link, War Thunder is giving you a free premium tank, aircraft, or ship, plus 3 days of premium play for free. It's a great deal. Thank you to War Thunder. And now today's video. Out there in the depths of our night sky sits a spectacular world of ice and fire. One of Jupiter's 4 Galilean moons, Io is so inhospitable it almost defies comprehension. A place where the frozen surface chills at an ungodly minus 130 degrees Celsius, even as its boiling lakes of lava churn at temperatures hotter than lava achieves on Earth. Drenched in radiation, equipped with only a thin, unstable atmosphere, it would be a place impossible to live on, even if it weren't for its most distinctive feature. Crisscrossed by over 400 active caldera, Io is a land of volcanoes, a place so volcanically active nowhere else in the solar system even comes close. Originally thought to be dead and inert, the 1979 discovery of Io's magma eruptions changed everything we thought we knew about Jupiter's moons. Ever since, we've studied this distant world intently, uncovering the nature of its relationship with the fifth planet, even as our discoveries reveal the nightmare nature of Io itself. If the biblical concept of hell was ever rendered in the physical world, there's a good chance it would look not unlike Io. The third largest of Jupiter's satellites, Io is a big beast with a radius of 1,821 kilometers, making it even larger than our moon. In fact, it's one of the 5 biggest moons in the entire solar system. But it's not its size that makes Io so hellish, so much as what's happening on its surface. As the most volcanically active place in the solar system, Io is a world of violent extremes. With over 400 volcanoes, Io looks more like Earth did several billion years ago than a modern celestial body. Here, jets of lava erupt hundreds of kilometers into the air, great lakes of magma ooze across the surface, reaching temperatures of 1,650 degrees Celsius, hotter than any we've measured on Earth. Yet Io isn't just a world of fire, it's also a place frozen in ice. Because it's so far from the sun, Io's surface temperature is around minus 130 degrees Celsius, or that's just really freaking cold in Fahrenheit. Now, that's warmer than most of the other Jovian moons, but it's still as cold as hell. So cold that a thick layer of sulfur dioxide frost covers the parts of the surface not being burned by lava. It's this frost, by the way, that's thought to give it strange colors, all greens, yellows, reds, and purples. Colors brighter and weirder than most other places in our solar system. We say most because you do sometimes get unusual colors around volcanoes on Earth. Yellowstone, for example, is famous for its bright pastel shades. Hence why scientists suspect a similar cause behind Io's surface. Surface the Voyage team memorably compared to moldy pizza. It seems likely vast sulfur deposits are to blame. But if you find these pictures of Io ugly, fear not. It won't look like that for long because of all the explodey fire constantly washing over the landscape. Io is one of the youngest surfaces of any astronomical body, a couple of million years at best, far younger than the 3 or 4 billion-year-old surface of Mars. That means Io is constantly shifting and changing, even as its siblings Ganymede and Callisto retain a similar appearance over colossal time spans. Io is like the younger arty sister, always reinventing herself. Although that youthfulness only applies to Io's outer appearance. A 2020 paper by Caltech professor Konstantin Batygin used powerful models to demonstrate that Io may have formed before any of the other Galilean moons, way back in the distant past, before Europa was even a naughty twinkle in Jupiter's eye. Yet it's not just Io's age age that's a source of ongoing speculation. Exactly what lies under the surface of all this ice and fire remains a tantalizing mystery. While many brainy space types think a subsurface magma ocean could span the entire world, it's equally possible there's a whole bunch of liquid-filled pockets dotted around. Not that there's much chance of us ever touching down to do some in-person tests. Aside from the extreme temperatures and violent eruptions, Io is additionally bereft of anything but the thinnest atmosphere as sulfur dioxide. In fact, it's so thin that it's been estimated Io's surface pressure is a billionth of Earth's. This weakness leads to some pretty strange side effects. Periodically, on its 42.5-hour orbit, Io swings out of sight of the Sun into Jupiter's vast shadow. Blocked from even the faint warmth of our faraway star, its lower atmosphere freezes, falling as snow onto the ground. There it stays until Io again emerges into sunlight and most of the snow evaporates. The parts that stay frozen, though, are perhaps even more interesting. It's thought to be interactions between lava and frozen sulfur dioxide that are responsible for Io's mysterious fields of sand dunes, a phenomenon previously thought impossible without the presence of wind. By now, you're probably thinking something along the lines of, well, this place sounds very nightmarish. Wouldn't want to live there. Yet, we've really only scratched the surface so far, so it's time to dig a little deeper into both what makes Io's volcanoes so special and into the other issue that would make it so dangerous to visit: the intense radiation. Of all the Galilean moons, none orbit so close to Jupiter as Io. Sure, there are a handful of smaller moons floating nearer to Daddy, but these are tiny compared to the 4 main satellites. Something like 99.9% of all mass circling Jupiter is locked up in Io, Europa, Ganymede, and Callisto. And that means Io is both close enough and big enough to seriously affect its host. At a mere 422,000 kilometers from Planet 5, Io's orbit takes it swinging across Jupiter's magnetic field, right through what NASA calls powerful magnetic lines of force. Now, we don't pretend to understand the science here. We're just history YouTubers who occasionally enjoy geeking out about space rather than being, actual astrophysicists. But Io's interaction with these forces causes some crazy side effects. The craziest being generating insane amounts of electricity. According to NASA, Io's interactions with Jupiter can generate up to 400,000 volts, a current which then flows along Jupiter's magnetic field lines, creating powerful lightning storms in the Jovian skies. And nor do the side effects stop with storms. Because Jupiter rotates so quickly, its magnetic field whizzes around like a child trapped on a malfunctioning fairground ride. As this repeatedly crosses Io, it strips up to 1,000 kilograms of material away from the moon each second, material that becomes ionized and joins a gigantic cloud of swirling radiation. But it's what happens when Io escapes this plasma cloud that's really cool. If you're a big fan of randomly geeking out over space pics, you may have previously spent an evening, probably while baked, staring at images of the flunky blue auroras Hubble and Juno have photographed at Jupiter's poles. Well, that's where that crazy light show comes from all these ionized particles escaping Io and getting trapped whizzing around Jupiter's magnetic field. In fact, so many have escaped that they've caused Jupiter's magnetosphere to grow to something like twice its appropriate size, a feat all the more remarkable when you remember just how tiny Io is compared to the behemoth that it orbits. Of course, this relationship isn't all one way. Like a large but tender lover, Jupiter gives back as much as it receives in the form of Io's volcanoes. Given that we live on a planet with volcanoes, it's tempting to assume the same forces that cause eruptions in Hawaii are behind Io's mountains of fiery death, but that is not the case. Rather, it's Jupiter's gravity that causes all these eruptions, or more accurately, Jupiter's gravity interacting with that of the other Galilean moons. Remember a moment ago when we mentioned how much mass Jupiter's 4 main satellites contain? Well, that means they're big enough to have serious gravity, and since they orbit at different speeds, the tugging of that gravity tends to affect each of them. In Io's case, Europa and Ganymede both interact with it on its journey round Jupiter, each time pulling on their sibling like they're desperately trying to drag her off for some planetary party. But because Jupiter's gravity is so strong, all this yanking achieves is to pull Io out of shape. As the moons enter resonance, Io's solid surface can be pulled a staggering 100 meters up into the air. Now, we see something like this happen on Earth. The moon's gravity tugs on the oceans, creating tides that cause sea levels to rise. But the highest tides reach only 18 meters. Io's crust is bulging over 5 times further every time it swings past its siblings. All that tugging creates intense internal friction that causes so much heat that it melts solid rock into molten magma. This is the secret of Io's volcanoes, why they're so numerous, why they're so powerful, capable of spewing ejecta nearly 500 kilometers into the air. But even knowing the mechanism can't explain everything about the moon's eruptions. One major headache Io causes scientists is in trying to understand the positioning of its volcanoes. The tidal heating model suggests they should be clustered near the poles, but they're not, nor can it explain the irregular outburst eruptions which are so intense the entire world seems to double in brightness. Yet these mysteries only add to Io's allure, an allure amplified by its alien magma, which seems to flow faster and cover more ground than earthly lava could dream of, or by its gigantic calderas so vast they could swallow a smaller nation like El Salvador whole. The largest of these, Loki Patera, sprawls across some 21,000 square kilometers, a molten lake of fire constantly renewing itself in a cycle of brightening and dimming that lasts over 400 days. Fascinating as all this is, though, it's not only what's happening in the here and now that makes Io so intriguing. Because there's another tale, one that sits alongside the story of what's happening on this distant moon, a tale that's almost equally remarkable. The story of mankind's relationship with Jupiter's explosive satellite. It was a cool, clear evening in January 1610 when the great astronomer Galileo Galilei peered through his homemade telescope at Jupiter and upended the whole of astronomy. At this point, the dawn of the 17th century, mankind was still living with the vestiges of an understanding of the heavens that dated from antiquity. There were still only 6 known planets. Serious, influential people still believed the entirety of creation orbited the Earth and not the Sun, and no one had ever before spotted a moon orbiting a different celestial body. On that chilly night of January the 7th, 1610, Galileo sighted Io, likely the first person in human history to set eyes on one of Jupiter's moons. But it was what came the next evening that proved really important. As he made further observations of Jupiter, Galileo recorded seeing 3 little stars alongside the 5th planet. Today we know these little stars as Io, Europa, and Ganymede. At the time, though, the astronomer thought there wasn't anything special about them. It was only when he decided to continue his observations over several nights that he uncovered the epoch-shaking truth. The 3 stars, later joined by a 4th, seemed somehow fixed to Jupiter, progressing with it across the heavens, always arranged in a straight line, even as they themselves moved. It didn't take someone as brainy as Galileo long to figure out that this meant those stars were orbiting Jupiter, and that meant they weren't stars at all. 2 months later, in mid-March 1610, one of the most important books in science history dropped in Venice. Known as the Sidereus Nuncius, or the Starry Messenger, it opens with an epic boast that the book contains great and surpassingly wondrous sights in 4 planets revolving with remarkable speed at differing distances and periods around the star Jupiter. They have been known to no one up to this day, and the author was the first to discover them. And so began humankind's journey, not just with Io, but with her siblings too. At least, that's the official version. Unofficially, there are at least 2 competing claims to Galileo being the first guy to spot Io, one kind of plausible and one less so. The less plausible claim comes from German astronomer Simon Marius, who 4 years after Galileo's big book launch published his own book claiming to have recorded all 4 satellites in late December 1609, a month before Galileo. The trouble is, Germany and Italy were at that point on 2 different calendars, and while Marius claims to have observed the moons in November, his first notes can only be dated to what in Italy was January the 9th, 1610, which is a full day after Galileo. The second claim, though, is harder to either confirm or deny. Way back in 365 BC, the Chinese astronomer Gan De was studying Jupiter and noticed what he called a small red star beside it. A star that some have suggested was actually Io. Because the Galilean moons are so bright, it's just about theoretically possible that Gandhi could have seen them with the naked eye, provided it was one hell of a clear evening and Gandhi had eyesight at the very limits of human ability. Since he died before Specsavers was a thing, we have no way of knowing what his prescription was, so the claim remains unsettled. Regardless of who was really first, though, it was Galileo who won at getting his discovery public. And that meant he got to name all 4 moons. This being 1610 and Galileo not being an idiot, the name he bestowed on them was the Medician planets, after his backers, the Medici family. Although the name was only collective, each individual moon had a number, with Io being Jupiter 1, it was meant to evoke the 4 Medici brothers, so a way of immortalizing Galileo's patrons in the heavens themselves. Only, of course, that's not quite what happened. Flash forward to the mid-19th century, and the discovery of additional moons around Saturn was making numbered systems look old and lame. As Saturn's satellites began to get funky mythological names like Titan and Enceladus, scientists began to wonder if it made sense to keep using the names of dead guys from Florence for Jupiter's moons. So they began casting out for new names, and they found it in the works of Simon Marius. Back when he thought that he'd been the first to spot the satellites, Marius proposed naming them after mythological hotties, writing, Io, Europa, the boy, Ganymede, and Callisto, greatly pleased lustful Jupiter. And it seems 19th century folk were absolutely down with this. They adopted Marius's idea. But since it didn't feel right taking all of the names from Galileo's rival and giving him none of the credit, it was decided to honor the Italian as well. From this point on, the 4 large worlds orbiting Jupiter would be known as the Galilean moons. The long decades between Io's renaming and the first probe sent to the Jovian system passed with almost no major changes. Perhaps the only one of note were the discovery that Io had more siblings than initially thought. On September 9, 1892, American Edward Emerson Barnard discovered the moon Amalthea, the first new Jovian moon sighted since Galileo's time. Sadly for Barnard, this became less impressive just 12 years later with the discovery of Himalaya. Today, with over 80 known moons orbiting Jupiter, it's even less so. No, for humanity's understanding of Io to really advance, we would have to wait until we'd crossed an important technological milestone, the ability to successfully send probes into space. Finally, in the mid-20th century, we got there. The speed with which our understanding of Io changed across just 6 years seems staggering today. In 1792, Io was just a faint pinprick of light beside Jupiter, a distant dot assumed to be as inert and lifeless as our moon. Yet by 1973, we'd taken our first measurement of it as Pioneer 10 whizzed by. A year later, in December 1974, Pioneer 11 took the first ever image, a fuzzy semicircle half obscured by Jupiter's shadow. But it would be what happened in 1979 that blew everything wide open. That's because 1979 is the year Voyager 1 went hurtling past on its long journey out the solar system. Equipped with far better cameras than Pioneer 11, it snapped photos clear enough for scientific study. When those photos were transmitted back to Earth, they contained something no one ever expected to see. JPL engineer Linda A. Morabito was the one in charge of examining the stream of images that morning, a process that would soon be automated, but in 1979 had to be done manually. As she examined one from the change of pictures, she noticed something odd, a bulge to the edge of the moon's surface that might be image distortion or might be something special. Luckily for Morabito, this definitely fell into the special category. That bulge was really a giant plume, a great cascade of lava shooting out of a volcano and into the Ionian skies. Morabito had just inadvertently discovered the first evidence of non-terrestrial volcanism anywhere in the solar system. The discovery that Io wasn't just some cold, boring ball of rock upended everything we thought we knew about Jupiter's moons. Suddenly, this distant satellite was no longer a dot, but a possibility, a geologically active place where all manner of weird and wonderful things could be happening. Perhaps it's no surprise that NASA decided to go back. Launched in October 1989, the Galileo probe was our first ever in-depth look at the Jovian system, a mission that studied not just Jupiter itself, but visited each of its major moons. From 1995 to 2003, that included multiple flybys of Io beaming back new pictures, expanding our understanding of this violent volcanic world with its ever-changing surface. And while Galileo would only visit Io 6 times, it wouldn't be the last time we got up close and personal with the moon of ice and fire. There was the Cassini probe, which briefly visited in 2000 en route to its main mission at Saturn. There was New Horizons, which checked in again in 2007 while picking up a gravity assist boost to make its way to Pluto. And then there was Juno. In orbit around Jupiter since 2016, Juno has been mostly studying the gas giant itself, but it's also taken time to study the old radio waves Io is emitting, and has scheduled in at least 2 future flybys to get more data, one at the end of 2023 and another at the beginning of 2024. Still, for all the spacecraft that have visited this fiery moon to date, there have been no dedicated missions, no individual probes solely tasked with unraveling Io's mysteries. But that's not to say scientists haven't tried. Yeah, it's time for the final chapter of today's video, the tale of how we've tried again and again to study Io in depth, only for each attempt so far to be stalked by failure. The sad truth about NASA missions is they're painfully expensive. Even the cheapest class Discovery missions require budgets in the hundreds of millions. With even the best will in the world, that means the agency can only fund so many proposed projects and certain stuff takes priority. It's just unfortunate that visiting Io has been one of the projects repeatedly deprioritized. The idea of a dedicated mission to Io first became a serious prospect way back in 2007 when NASA asked for additional work to be done on a concept study. By 2010, the Johns Hopkins University's Applied Physics Laboratory had a mission outline solid enough to pitch to the Discovery program, the same program that funded the Dawn mission to the underrated dwarf planet Ceres. And what a pitch it was, eventually evolving into something known as the Io Volcano Observer, or IVO. The plan was for a probe that would investigate just how the gravitational tug-of-war between Jupiter and Europa and Ganymede makes Io so volcanic. Over 10 separate flybys, the IVO would sweep down close to the moon's Hellish surface, coming within just 200 kilometers of the lava-soaked ground. As it dove, it would take scores of photos until maybe 90% of Io's surface had been imaged in high resolution. But the coolest part would be the videos. With each flyby timed to coincide with periods of intense activity, IVO was intended to capture stunning up-close film of Io's volcanoes blowing their tops, like a non-CGI version of the fire planet at the end of Revenge of the Sith. Of course, it wasn't all going to be cool footage and volcano photos. The idea was for IVO to determine what lay beneath Io's surface, while also searching for clues about how early volcanism might have played out on Earth billions of years ago. At its best, the mission offered a chance to peer into the early days of the solar system when Earth and Mars were alive with fire. Sadly, though, that wasn't quite good enough for NASA. After failing to make the Discovery shortlist in 2010, the idea hobbled on for the next decade. In 2013, a modified version was one of the projects recommended in the Decadal Survey, a once every 10 years list of what planetary scientists think is the coolest shit that we could do next. Often, inclusion on the Decadal is a good sign that there's life in a project, but if there was, IVO stubbornly refused to show it. Rejected again in 2015, the project was repitched once more to Discovery in 2019. This led to a flicker of hope when it was selected to be one of the 4 finalists, alongside 2 missions to Venus and a possible mission to Neptune's moon Titan. That flicker soon faded. In June 2021, NASA announced that the 2 Venus probes, known as Da Vinci and Veritas, had been selected for funding. After coming so close, IVO had once again failed to ignite enough passion. At time of writing, there are no known plans to repitch the project. Sad as this is, we can't pretend to be that cut up about it. We've actually got a Venus video in the works right now, which will absolutely feature a chapter with me geeking out about Da Vinci and Veritas and all the awesome stuff that they are going to do. But still, there is a hint of melancholy in our current ability to return to Io, to a world so fascinating, so complex, and so unlike any other. In all our solar system, active volcanism has only been confirmed in a handful of places: Earth, Io, Triton, and Saturn's moon, Enceladus, with unconfirmed volcanoes or cryovolcanoes suspected on Venus, Ceres, and Europa. Of all these, none hold a candle to Io, a place so explosive even its smallest blasts would make Krakatoa seem like a wet fart. At a time when NASA's attention is deservedly turning to ice worlds that may support life, it's good to remember that frozen water and subsurface oceans aren't the only things worth investigating. They aren't the only things that make a moon interesting. Because in Io, we have one of the weirdest, most intriguing bodies in the solar system. A world of ice, yes, but also fire, burning brightly in our skies. A place to which we will, hopefully, one day return. Thanks again to War Thunder for sponsoring today's video. Remember to follow the link in the description below to start playing their free vehicle combat game with 3 free days of premium play and a premium vehicle as well. Go check it out, and thank you for watching.